Hi everyone, this is lesson 1.3.2, angles formed by transversals. In this lesson we continue talking about angle relationships, just like on the previous lesson, except this lesson is specifically on corresponding angles. All right, so most of the notes will be focused on that. And so in these notes, we're looking specifically at what happens when you have a line, which we call the transversal, and when it intersects two parallel lines. Right. So in this diagram, I have parallel lines drawn out, and the names of those lines we call L and N. Right. So lowercase L, lowercase cursive L, and cursive N. Those are our parallel lines. So L is parallel to N. That's this notation. These two bars means parallel. L is parallel to N. And M, this line here, you'll notice it cuts through these parallel lines. Kind of like how a road, a street might cross over some train tracks. So we have train tracks and we have the street that crosses over those train tracks. In that case, the street would be our transversal, and the train tracks would be our parallel lines. All right, so M is a transversal. This is a vocab word you need to know. And again, M intersects both lines, not just one of them, but it intersects both of those. All right, so that's kind of the basics of corresponding, or that sets up the basics for corresponding angles. This is the situation we're looking at. In this situation, we have a lot of angle pair relationships going on. And I think in the next lesson, we'll probably look closer at all of them. But for the most part, the definition that we're focused on is corresponding angles are translations of each other along the same transversal. What does that mean? Translations, this is an actual vocab word you should know from transformations. There's different types of transformations: rotation, reflection, translation. All right, so translation means basically to slide. And so if I take one angle, like for example, I've kind of highlighted, let me highlight it a little bit clearer. So if I take this angle B, and I take this angle B and I translate it, you'll see I could actually slide it. Translation just means I'm sliding it, but I'm sliding it along the transversal, right? I'm not sliding it anywhere else, but along this line. So if I slide it along this line, you should notice it fits perfectly on top of the X. All right, so in that case, I would say that those two angles are corresponding angles. So that would be an example of corresponding angles. And so, do we have any other corresponding angles in this picture? Well, if I look at other ones, like if I say angle A, does that correspond with any other angle? Well, let me highlight that for us. So let's say I'm looking at angle A. If I slide it, you should notice it fits perfectly at W. All right, so those two would be the same. So I'm going to color them the same. All right, so A and W are the same. Are there any others? Well, we could do this with all the other angles as well. So angle C, this angle, it should correspond with angle Y. And you should also notice angle D might correspond with angle Z. All right, so you'll notice, and I have those written down for us as well. So angle X and B are corresponding angles. Angle A and W are corresponding angles. And then I've also listed out the other ones as well. Y and C and D and Z. Right. So keep in mind these are angles, not less thans. I know sometimes they look like less than. I try to make them look like angles. All right, so those are examples of the angles that we call corresponding angles. All right, so the nice part about these is that corresponding angles are congruent. This is kind of key. So why do we care if they're corresponding? Well, if we know that they equal to each other, then that means we have a nice equation we could solve. All right, so we'll look at some examples of that. So let me move this forward. All right, so I set up a problem for us. It's partially answered, but I'll just talk about it. So here's a situation where we have parallel lines. And there's a line that goes through them. So that means we have a transversal and we have parallel lines. All right, so that means somehow we have corresponding angles in this picture. So I noticed there's a measurement given to us, 135 degrees, and there's this other angle called x. Right, so if we're trying to figure out what x and maybe y are, we could use our angle relationship. So we just learned about corresponding angles, so then the question is, do I have any? Right, so if I highlight these, let me highlight these for you. So if I take this angle, 135, and I translate it, if I slide it over, you'll notice it fits perfectly on x, which means they are the same angle. So that means I could say that x is equal to 135 degrees. And what's the reasoning for that? So not only do you need to understand what the measurement is, but why. And so the reason is because corresponding angles are congruent. So that means they must be the same. So then the second part to this question is, well, then what is y equal to? Well, if I completely ignore this side, and I only focus on this part, you should notice this is a situation where we have two lines that intersect and we have vertical angles. Well, I remember from the last lesson that vertical angles were congruent. They're the same measurement. So if this x is 135 degrees, then this y must also be 135 degrees. All right, pretty easy. There's really doesn't seem to be any work here. The work is you knowing that these angles are congruent. So once you know that, then there's really no work to be done. So that's the nice part about these problems. So the reason for this last one is vertical angles are congruent. Right? So those are two things. We just learned corresponding angles are congruent. And I think the last lesson we learned vertical angles are congruent. So we're going to start to build this collection of skills on determining angle relationships. All right, so here's a couple more for us to try. I'm going to work these out with you. You'll notice some of the same, they're actually the same numbers, measurements, except just different situations. I'll zoom into this. And so, same situation, parallel lines, transversal. So I have again 135 degrees. So I'm going to highlight this. And so the question is, let me make that smaller. So, all right. So if I highlight that angle and I translate it, I notice it fits perfectly on x. All right. So then I could say, in this case, that x is equal to 135 degrees. Then what is y equal to? Well, in this situation, the last one, x and y were vertical angles. Now, x and y, they're right next to each other. And you notice they form what we call this straight. They connect to form this straight line, which is called a linear pair. And the angle relationship is supplementary. So this was from the last lesson. Everything we covered on the previous lessons, you're going to have to remember. So make sure you look at your notes if you don't remember that. So x and y should add up to 180 degrees, which makes sense because look, if I draw this, that's half of a circle. And for those of you that might remember, a full circle is 360 degrees. So half of that, it should be 180. All right. So if the x is 135, the question is, what is y equal to? Well, y must be equal to what we do know is x plus y is equal to 180 degrees, which means we could say 135 degrees plus y is equal to 180. So if we solve this, y should equal to, what is that? 180 minus 135. So this should be 45 degrees. All right. And we'll do one more. And so on this one, the reason why I want to go over this one, you'll notice it's a little bit different. It's very similar, has all the same numbers. So what usually happens when people see a problem like this is they'll say like, oh, okay, I get this. This is pretty easy. So this is a 135. Oh, look at these two. These together form a supplementary. We've seen this before. We just saw this. So if that's 135, then y must be, what is this, 45 degrees. All right. Because y plus 135 should equal to 180 degrees. All right. So that means y must be equal to 45. So the issue here is with x. So on all these previous problems, I took this 135 and I translated it. But you'll notice if I do that, it doesn't fit perfectly. Why doesn't it fit perfectly? Because every single time. Now, this is a transversal. I could slide it along the transversal and it's supposed to fit. If I slide it on this other line, that's not going to do us any good anyways. So the question is, how come it doesn't fit? Well, if you didn't notice, these two lines are not parallel. So there's no symbols that say they're parallel, not like these. We saw it on this example. These are parallel. But on this example, we don't know if they're parallel or not. They could be. Maybe I just drew it poorly. And these could be parallel lines. But if we don't know for sure, then we could assume that maybe they're not. And then you'll notice these lines will probably intersect, which is not good. So this one, so in order to figure out this one, we would really, there's not enough info. All right, so there's not enough info to figure out what x is. So in some cases, we could figure it out. In some cases, we can't. The key is, do we have parallel lines? All right, so this leaves us with our last, this is the last part. There's a conditional statement. If you don't know what a conditional statement is, it's a statement where we have if, then. So if this is what we have, then this must be true. So if it's raining outside, then the ground is wet. So that's a conditional statement. So based on what we just finished talking about, this is something you need to know. If lines are parallel, then corresponding angles are congruent. So in this previous example, 135 and x, these are corresponding angles. So these are corresponding angles, but they're not congruent. Why? Because we do not have parallel lines. So I could still call them corresponding, but I cannot say that they're congruent. On the other examples, we do have parallel lines, therefore they are going to be congruent. So this is a statement that you need to be familiar with. It will come back a little bit later. All right, so that's it for these notes. Hopefully it wasn't too complicated. As usual, if you have questions on any of this, please let me know and I'll do my best to answer those questions. All right, thank you very much.